In this podcast, we will determine how to calculate the mass of a compound. It will also be the introduction to moles. Alright, so how do you determine how many atoms of each element you have in a compound? Let's say we had C6H2O3. You have 6 carbons, 2 hydrogens, and 3 oxygens. What if you had something like this? There aren't any little numbers on the bottom, but they're understood to be little pretend ones there. Okay, so there's 1 sodium and 1 chlorine. Now sometimes you have things like this. Okay, so you have 1 magnesium. Now you have these parentheses. Well, the parentheses work just like in math. So that 2 is going to distribute in. Okay, so you have 2 nitrogens and 2 times 3, 6 oxygens. Okay, so now that you know how to count the number of atoms of each element you have in the compound, how do you determine the mass of the compound? Well, let's go back to our C6H3O2. All right, the first thing you want to do is you want to write all the elements you have in the compound going down like this. And then you write how many you have of each element. We just went over how to figure that out. It's the little number on the bottom. Now you're going to multiply that by the mass of the actual element itself. So look on your periodic table, find carbon. Did you find it? Alright, so if you look at carbon, the bottom number under carbon, that's the mass of carbon. 12.011. Okay, now you want to do this for all the elements. So find hydrogen. What's the mass of hydrogen? 1.0079. Alright, and oxygen? 16.00. Good job. Okay, so now we're going to multiply going across. So we got 32. 3 point, let's break out the calculator here, guys. Alright. So 3.0237. And then we got to do our carbon. So we got 6 times 12.011. So we got 72.066. Okay, so all we've done is multiply going across here. Now you want to add going down. So add them all up. Bring our little handy dandy calculator back out here. Alright, we already got our 72. So we're going to add 3.0237 and 32. Alright, there is the mass of the entire compound. 107 point, forgot the rest of it, 0897. Okay, now this is the mass of this entire compound. What's the unit for mass? Grams. Okay, so you got to put a little g beside it. Okay, so that's how we calculate the mass of the compound. Alright, so you've been hearing this little word mole. What exactly is a mole? Well, a mole is a unit. Okay, it's the SI unit for the amount of a substance. You're probably thinking, what does that mean? Okay, well, what 1 mole tells us is that any compound we pick, 1 mole of it will be equal to the molar mass. Now, what's molar mass? Molar mass is what you just learned how to calculate. It's the mass of the entire compound. So if we wanted to know how much 1 mole of C6H3O2 weighed, okay, what's the molar mass of 1 mole? It would be equal to what we just calculated. Okay, so the 107 point, what was the rest of it? 0897. Okay, so 1 mole of any substance is equal to the molar mass of that substance. Well, we can use that fact to convert using dimensional analysis. Okay, so how many grams are there in 3.5 moles of H2O? All right, well, you got 3.5 moles. Okay, that's what we're starting with. We know we're going to convert. And if you remember, our conversion factor for mole was 1 mole is equal to the molar mass, okay, in grams. So if you have a mole here, you must have a mole down here so that they cancel out. Well, how many moles do you have in your conversion factor? Just 1. So you have 1 right there. Now, that is equal to the molar mass of H2O. So we got to go down here real quick and find the molar mass of H2O. So we got hydrogen, there's 2 of them, and we have 1 oxygen. We're going to multiply by the molar mass of both of these elements, okay? The mass, the number on the bottom of the periodic table. Okay, so we got 16 and 2.0158. All right, now we're going to add those up. Get 18.0158 grams. Now that number, the molar mass of H2O, of water, goes right here. Okay, now it's just a simple math problem. So 3.5 times 18.0158. All right, 63.0553. Okay, now our moles canceled, so this is grams. Now, of course, you have to sig fig. There are 2 right there. So there's your answer. Okay, let's try another one. Okay, how many moles are in 4.5 grams of HCl? All right, well, we got 4.5 grams. Okay, and remember our conversion factor was 1 mole is equal to the molar mass. Okay, so if you have grams here, you got to have grams here so that they'll cancel. Now, looking up here at our conversion factor, where is the grams going to be? Oh, yeah, grams is mass, right? Okay, so we got to find the molar mass of HCl. So you got 1H, 1Cl, and multiply by the mass of the elements themselves. So you got 1.0079 and 35.453. And we're going to add those up. Break back out our little handy dandy calculator up here. Whoopsie. Alright, so we got 36.4609. Okay, so that number is how many grams are in 1 mole of HCl. Okay, now this is equal to what? It's equal to 1 mole. So we're going to put 1 mole on the top. Now you can abbreviate mole, M-O-L. I know you drop off one letter. How exciting, right? 4.5 times 1, 4.5, divided by 36.4609. Okay, handy dandy calculator. 4.5 divided by 36.4609. Alright, I got 0.123. Now your unit's moles, right? Alright, now sig figs. 4.5, that's 2 sig figs. Here's your first 2 significant. That 3 won't make that 2 round up, so we can just drop that off the end. So 0.12 moles.